In this video, I'm going to be teaching you about independent of part and positive function. This is the topic. Okay, I will before I deep into this topic, right? I need you understand the previous example, right? Previous example in the right example. Example number 2. I taught you this case, right? This case is the curve function generated from the coordinate point. The coordinate point number 1, 0, right? 0, 1, x 0, y 1. Okay, point 2. Okay, drawing the start point to the end point. You got the curve, right? And the end point is x1, y2. And okay, you generate the curve function by the linear curve formula. Y equal to mx plus b, right? Okay, you got this, the function, right? The equation of uh, uh, line equation, right? The straight line equation. Okay, you got this, right? Okay, the start point is 0, 1, and second point or the end point is 1, 2, right? Okay, going back to the new topic, I'm going to be teaching you now, right here. Okay, this is the point, the previous example. 0, 1, 2, 1, 2, right? X1 and okay, x1, y1, x2, y2, right? Something like this. Okay, in this case, if I keep the start point and the end point the same or the previous example, right? Okay, you see one point. And but okay, the red color. Okay, another example. If I put intervene 0, 1 and 1, 2, right? Okay, put intervene that. Oh, become to this graph, right? This graph I plot connect point to point, right? Point number 1, 0, 1, and point number 2, 1, 1, and point number 3, 1, 2, 1, right? Sorry, x1 to y1, x1 to y2, right? Okay, got it. And the previous, right? Okay, the end point, the start point the same, but okay, you found it. Okay, this this the different, this is the different part, right? Different part. Okay, different part. For example number 1, right? No, the previous example, a part is the, okay, have is there is the slope, right? 1.1 to point 2, there is the slope. And this one, okay, another case, okay, this is the 0 is 0, right? Okay, separate to curve. To curve, linear curve number 1, okay, the point 0, x0, y1, and point number 2, x1, y1, right? Okay, like this, the different part. Okay, this is the different part. Okay, uh, how do I explain this situation? Okay, this one, this previous one, previous example, previous example, right here. You got the result. Line integral value is a line integral value for the case number 1. Right? Line integral value, right, for case number 1. This is the integral line integral value for case number 2, right? Case number 1, right? For the special case, I put in between start point and the end point, become to split, become to be split to two curve, right? Curve number 1 and curve number 2, and finally you must summarize both curve. Okay, you got the final line integral value. Okay, the curve number 1, the function is curve for curve, is for this curve number 1, y equal to 1, and find out differentiate y. Okay, you got y0, and when y0, okay, the second term is gone. right? It's been gone, right? Okay, and this equal, and integrate is the function curve. Integrate is the line integral for the curve number one. You got negative 2/3. And second curve in the special case, uh, x1 initiate, right? Initiate 1, right? We come to 0 and dx 0, right? When dx 0, okay, the first term had been gone, right? It had been gone already, right? Okay, you got the result, right? You notice the limit, limitation, right? The definition, definite equal, right? Definite equal 0 to 1, right? Because go along, you notice along is x, point 1 to point 2, along is x is the first term, first the coordinate, right? First coordinate 0 to 1, because this is x. Okay, this is x. Okay, y, x1, y1. Okay, this x2, y2, right? Okay, I got a result. I got a result 10/3. 10/3 if you run about integral operation. Integral operation, you got the result 10/3. And okay, both line equal, both line equal value. You summarize together. You got the value final result 8/3. Okay, you notice the value, line equal value for the case number one. Okay, the point number one to point number two left side, right? And case number two, okay, the right side. Actually, this one, the start point and the end point, the same. Okay, little bit different. The little bit different is the case number two. Insert a new point between point 0, 1 and 1, 2, right? And this is causing the line equal speed up to curve, speed up to curve, right? And that means why you need to summarize the line equal value for curve 1, for curve 2, and curve 2, right? Like this. And the result is different because the path different. Each part different, causing the line equal value is different. But and in this topic I propose the way to solve the right equal, and you must check it out about f vector, because maybe some f vector, okay, is a special. It can be solved by the potential function. Use the potential function solve, and okay, you got the result. On it never depend on the part. Okay, just if start point the end point the same. If vector, okay, check it out, the vector is can be find out the potential function, and that solution, okay, it come from the end point minus the end minus the start point. That's it. Not depend on the part anymore, right? And but you must check up about f vector. It can be find out the potential function, and it can be independent of the part or not. Okay, how to check it out? Okay, check number one, how to check del cos f. If you operate okay, put in the operator del cos to vector f, and you got the result, you will get the result 0. If you got the result 0, okay, you guarantee and ensure vector f can be independent of the part, right? Okay, it is equal 0, it's good. And next step is going on to solve, right? To find out. Okay, it keep when the step number one true, and step number two should be true, and two. Case number two, step number two, f vector equal to del phi, and del phi is the potential function, right? This is the potential function. Okay, let me delete it. This is the potential function. Okay, this one potential function. And okay, so maybe some word I forgot in. Okay, let me check and correct this word. Dependent. Okay, dependent, right? Okay, this one. Sorry, I I was wrong. Typo. Is it typo? It's wrong. I will put in this the independent, right? Independent. Okay. What is your function? Example, right? Example. I will show you how to use. Check it out. Formula. Check it out. The formula. Okay. Proof with vector f. Cos del cos vector f should be 0, and the example it can be 0 or not, right? Okay, check it up before you dive into solve that the problem related on this topic. Okay, number 2, if you done about and you got through about case number 1, step number 1 already. Okay, you can keep f vector equal to del potential function. Okay, example. Determine vector f equal y square I plus 2 f y plus 3 j and plus 2 y k, right? Okay, form the start point 1 x 1 y 1 z 0 2 okay x2 y2 z 0. Okay, determine the line integral, right? Determine the line integral value determine the line integral value f equals something the component ijk from this point to this point. Okay, if f vector to be the independent, it can be independent of the path, right? Okay, you can focus on the start point and the end point. That's it, because it not depend the path, right? Not depend the path anymore. If vector f can be independent, how you check it out? F to be the independent part, right? It's a spatial. It's spatial. It can be uh, finding the potential function from the vector, right? Okay, check it out. Del cos f. And del cos f equal in the formula del cos f, right? Okay, curve r by curve y, curve q by curve c. Okay, is a component I plus curve p by curve c, curve r by curve x, j, and k, curve q by curve x, and curve p by curve y, right? Okay, what is r, what is q, what is p, right? Okay, I told you before. Okay, the font of I. This is P. Right? This is font of J. This is Q. Okay, this a special name. I naming. I naming is the font of. This is the coefficient function. Font of the I define to be x p, and the font of the J I define the name b q, right? And this one last one to be r, right? To be r. Okay, you use this formula and compare with the component I, J, K, font of the I to be P, right? And R, right? Okay, you can define the P is Y square, Q is 2xy plus C, and R equal to 2y. Okay, uh, you you operate. You operate when you okay, sorry, you operate the differentiate the evaluation to the p q y compare with z curve p by curve z, right? Okay, curve p y and curve by curve c. Okay, zero, yeah, all right, it's curve c by curve p by curve z, zero. Okay, and this curve p by curve c, and curve r by curve x, right? Curve r by curve x, okay, become to zero again because it's just only y, and the only y never have the c variable in the function r. Okay, where this pair is okay become to zero. Okay, become to zero. Okay, another pair I use black, magenta color. Okay, this pair curve q by curve x, curve q by curve x, right? Curve q by curve x, this one. Okay, right, it's curve x. Okay, 2xy plus 2z, 2z, right? Curve x. Okay, this one 0. Okay, this one 2y, right? Okay, we got 2y. Okay, this 2y. Another one for this pair. Okay, this pair q curve x and curve p by curve y, curve p by curve y, 2y, right? 2y, curve p is py, curve p by curve y, right? Okay, curve p by curve y. Okay, this 2y. Okay, it will become to 0 again. Become to 0. Okay, next, orange. Curve r by curve y. Curve r by curve y. Curve r by curve y is 2, right? Curve r by curve y is r. Curve r by curve y become to 2. And curve q by curve c. Curve q by curve c. Okay, the first term 0, 2, right? So okay, it's the same, equal, the equality is this body. Okay, become to 0. Okay, that means check it out. It's the first step. Checking out for f, the first step, you got 0. Okay, did you confirm vector? You confirm vector f, right? Can be found. It's it can find out, right? It can find out. Okay, potential function can be find, can be finding the potential function, right? Oh, sorry, the potential function, potential. function. Okay, that's good. Okay, that's good. Then so you got another formula vector can be okay del phi, right? Okay, if it's del phi already, you must solve the problem. Solve the problem. Next step, because it's del f equal, okay, del is e curl phi by curl xi, right? Xi and curl phi by curl yj and curl phi by curl z k, right? K. Okay, vector f is pi plus qj plus rk, right? Okay. Okay, I put in the problem given function f vector, and the f vector come to the right side, y plus I plus y square j, y square I 2 to xy plus kc j, right, plus 2yk 2yk. Okay, so back 100 curl phi by curl x I curl phi by curl yj plus curl q by curl ck. Okay, compare together both sides. Okay, you see here font of I, okay, equal to font of I right side, font of I left side. Okay, compare with the equal y square equal to curl phi by curl x, and this curl phi by curl y equal to the second term font of j, and is the font of k right side equal to the font of k left side. Okay, I add new page. Okay, set up curl phi by curl x equal y square, the equation number one. Equation number one, curl phi by curl y equal to xy plus c. Okay, for the second equation, and the third equation, curl phi by curl c, curl phi by curl c equals to y, right? To y. Third, okay, you take from you take equation number one from equation number one, from equation number one, curl phi by curl x, right? Curl phi by curl x equal y square. Okay, I take this curl phi, take the integral side, y curl x, right? Okay, integral. Okay, you got a function. Okay, it's fine. It's okay. Integral with respect with x, right? And keep y constant because uh, relate on x is not relate on y, right? Because you keep y constant. Okay, I will you get the solution for right side integral. I got this y square x, right, plus, okay, it's constant. The constant value because I keep y constant, right? Maybe maybe in the constant term, it's possible, possibly the function depends on y, right? And y, oh, and z constant too. And let's see, y and z keep constant, right? And it correlate on x, right? Only x, right? Okay, that means, okay, and z c2, c2, y and c as well should be as constant, right? Possibly constant. Okay, this is equation number 4. Equation number 4. Okay, so should be solving about the function y c. What is the y c constant? Okay, you should be solving. Okay, you should be solving this function. Okay, assume it's constant, and constant because I declare to the function and respect with x and y and c constant, right? Because it is a multi-variable. And what is the function yc? You must you must find you must you must find this function. Okay, okay, from equation number 2. Equation number 2. Okay, equation number 2 is curve phi by curve y equal 2xy plus c. Okay, here by x plus c. And then, okay, it's fine, right? Equation number 4. Equation number 4, right? Okay, curve phi x y square plus function y c, right? Y equal to x y plus c, right? Mm. Okay, differentiate this one to this term, first term, 2xy and plus, right? Okay, expand inside of bracket, you get curve phi y, curve phi f, function f, and two variable y and z, right? Curve y, and another side is 2xy plus c, oh, plus 2c, right? Okay, compare both sides. Okay, reject can be rejected, and can be rejected in the first term of left, first term of right. Okay, you got it. Line, you got the line. Curve fy, sorry, yc, right, and 2z, right, curve y, take it equal both sides. Okay, this uh, this answer right side 2z because it's constant, equal compound let's spec with y, right? Y, right? And the other side, okay, function y c, and it's plus. Okay, keep z constant, right? Keep z constant, g z. Because just only y and c, and okay, keep c constant, indicate respect with y. Okay, the left of the term, okay, the term is the constant, should be g3 variable, right? C independent variable, right? And you didn't know about gc is, right? You must find out next equation. Okay, find out from next equation what is the g function. Okay, from uh, sorry, and use this one different color from three equation. Okay, fine. This function I assign to be five, five equation number five. Form three and uh, take equation number five to equation number four, to equation number four. Right. Okay. Right now you got the potential function equal equation number four, x y square plus 2cy plus dz, right? Okay. Equation number six, okay, from equation number three. Okay, let me, okay, remove this. Okay, I put is better. Put, okay, put equation number five to equation number four, right? Okay, from three is curve phi by curve c equal to y, right? Okay, and equation six, right? Okay, curve c, equation six is x square xy square plus 2cy plus gc, right? Oh, c and 2y. Okay, 0. Okay, 0. Sorry, 0 plus 2y, right? 2y plus d, because it's one variable, it's not multiple variable, right? Because in the independent variable, it's just only one. Okay, okay, the very independent variable, the one variable c was was only only one variable, right? Okay, this is this g, right? G, because of one variable. It's not multiple variable anymore because it depends on one variable. Equal to 1. Okay, and y, both sides compare together. And 2y right, 2y right, 2y left, same, right? Same term. Okay, I just that both can be cancelled, can be cancelled. Okay, dc g c equals 0, right? Integrate, right? Okay, c. Okay, 7. Okay, put 7 to 6, right? Okay, become 2 here. Okay, x, y, z, this x square, x, y square plus 2cy, 2cy plus c. Okay, done. Okay, done. This question. This is a potential function. This, right? Potential function. Okay, this is a potential function, right? Okay, if you need to find out the radical value, right, for this problem, okay, here now it is on start point at the end point. Okay, just only depend on start point and the end point. The path is not affect anymore, right? Not affect to the vector f anymore, because the vector f you proved it already. Del cos f0, that means it can be independent the path, right? Okay, that means you just use the coordinate 110, 220, right? 110, the line indigo. The line indigo. Find the line indigo from point 110 to 220, right? Okay. Vector f dot dr, and right now become to define already. Okay, you just sub substitute the coordinate, right? This x1, y1, c1, x2, y2, c2, right? Okay, put in here, okay, x, find x, find 2, okay, find the potential function to 1, right? Find 1, 1, 0, minus, oh, sorry, 2, 2, 0, minus 5, 5, 2, 5, 1, 1, 1, 0. Okay, to 1, y, x2, right? 2 square, right? Plus 2, 0, right? 0, y2, y2. Okay, C don't care C, right? C minus C, okay, rejected. It can be rejected together. That means C, okay, it doesn't matter to count it in, right? Okay, minus 1, 1 square plus, I did it on the function, right? Okay, 2 C0, Y0, Y1, right? Plus, okay, this is plus C, the plus C and cancel together equal 8. 0 minus, okay, 0 minus 1. You got the right indigo value is 7. The line indigo. The right indigo. Okay, done. Okay, that's it. This example done. Okay, you prove after you prove del cos f, right? Prove del cos f equal to 0, and and sorry, and the curve vector dot dr equal the exponential function, right? Okay, this is the one. That means, okay, you just care about the point, the end point minus the start point. All right, the price is not affect anymore to the line integral, because this is the proof already. The vector f is spatial. It can be independent the part, right? And you must check it up about they'll call f first, right? It's the spatial f vector. Okay. The next topic. Next topic. You should know in my course, uh, in the three spread, I need define the condition coordinate on the three spread, and there is the some surface based on the Cartesian coordinate x, y, z. Like this, refer to my picture. It's below this topic. Okay, this topic is surface integral. It's the first surface integral. We need to find out vector f dot d sigma, right? Integrate. This is surface. Okay, this is the idea, the concept. Surface integral. And the 3D space, there is the surface based on the 3D, uh, right here in my picture. The surface, the orientation, and the uh, curvature on the surface defined by the normal vector. Normal vector is right angle to some point on the surface, and the orientation is the normal vector. It's a move around is the surface, and orientation is change. Degree is changed around to the surface, related on the curvature and how the flexible surface is. Right? Okay, on my picture, like this is the n defined by the normal vector on the some point the surface. Okay, the surface element, the small element on the surface, I cut it off. Right, a small element. Define this surface area of the small element is d sigma. Right? This is d sigma. This is d sigma. Okay, d sigma is a small element, and that point is d sigma. and okay, define the orientation of the surface with n vector. This is unit vector, and if you need to find out and figure out f dot d sigma, need the surface integral, right? Surface the vector field dot d sigma. Okay, compare with the right integral. Right integral use the f vector dot dr dot dr. This is a called is a line integral, right? You have learned everything. I taught you before. This the go along is the integrate go along is curve, right? It's curve and dr, right? The curve vector and a dot f dot the curve, right? This dr and along is a curve. I define by curve, indicate integrate operation and curve. Okay, and this topic is changed. It will be changed to the 3D f vector dot d sigma. Okay, go around the area of the surface, and okay, I have the technique. I have the trick to teach you how to find out f dot d sigma. Because this is the 3D space, right? And okay, it's too difficult to to find out the solution. The solution is the difficult, right? Difficult if you focus on the 3D. And I have the technique. I have the technique uh, to solve the problem. Right? Okay. The project 3D to the 2D project to the 2D pane, 2D pane. I have three standard pane: XY pane, YZ pane, and XZ pane. And this is standard pane. Okay, there are three pane. Okay, I define and I teach you just only one pane. I focus on XY pane. Okay, before you dive into the more detail, I just define n vector is n is unit vector, and I have the surface, right? Stay on the 3D space right here on the picture. I define this surface, right? G function G, the function G, x, y, z, multivariable, x, y, z equal to c, equal c. This is the surface function, right? In this case, surface function is G equal to c. Okay, if you need to to find out the unit vector, okay, if you remember the unit vector is what is the formula for unit vector, if you remember. Okay. The unit vector, the vector for the surface gradient, right? The del G, del is the operator. Curve by curve x something plus curve something by curve y yj, right? And curve something I by curve x plus curve something by curve yj plus curve something by curve z, and okay. And this is the del, right? Is the operator, one operator of all the mathematical engineering, right? When engineering is a lot of the operator, the derivative, right? The operator, integral, right? The operator, and is the one of them. Del is the operator, right? Is I. Okay, if you need to del G mean you will get curve G by curve xi, curve G by curve yj, curve G by curve z k. This is the del G. And if the unit vector, it has and must have, right? It must have. Okay, it's correct. It must have. It's not just it has we call it mass. There is the magnitude of del G. Okay, divided magnitude del G. Okay, and del G I just rewrite on the next slide. Del G K the curve Y curve X. Sorry, uh, I made a mistake. Del curve G by curve xi, curve G by curve yj, curve G by curve c, k. Okay, okay, divided, divided by the magnitude, its magnitude, n vector, curve G by curve x square plus curve G by curve y square, curve G by curve c, k. This is the formula of the unit vector. Okay, define how it's flexible. The surface is okay, defined by normal vector and unit normal vector. And don't forget plus and minus. Plus and minus mean in the some surface is a minus, maybe you define the hole on the surface, you define the hole by minus, and the negative is the non-unit vector, and the positive of unit vector is okay, in that area there is the surface in that point, in some point on the surface, okay. Plus mean okay, there is the surface, and minus mean okay, there is no surface, and okay, mean the hole is a hole on the surface. Okay, and how to solve in the surface integral, because it is 3D, right? I told you about if you solve it, this is a problem, the surface integral, you must project to 2D, because you solve around its area is easier than solve by space, and space is difficult. Okay, I suggest you this technique. Okay, you look at take a look at the my picture. It's a my picture, right? Okay, there is the space. Okay, uh, just stay on my space, right? Okay, if you need to solve surface integral, you just project. This is just a project the 3D space to some plane. Okay, in this case, I just project on XY plane, XY plane like this. Over here, this is a region in the XY plane. After I take it, I projected the surface, right? The floating on the space, right? I project down to the plane, XY plane. Okay, I will get this. Okay, you focus on the area d sigma. Okay, I explain you d sigma is after you project to the 2D. d sigma d sigma is a vector. No, it's not. D sigma is scalar. I just this is a scalar. I project. If you need, I need to project down to the XY plane. Okay, the project, the unit vector is up there, the point up, okay, right angle with the XY plane. The point up is the mean the unit normal vector for XY plane unit, and that unit is k, unit k. And k, I define the normal to the xy plane. Unit vector is k, right? It's k. If unit vector go around is x, I call that I. Unit vector go along is x-axis I, go along is y-axis J, go along is z-axis K, right? And right now it's project down to the xy plane. Normal vector of the xy plane is k vector, right? Okay, and in that point, the same point realization is some area d sigma, okay, defined by normal vector, defined by the normal vector, right? D sigma, okay, the curvature on that area, D sigma defined by normal vector n, and okay, some this case it just project down to the 2D plane, xy plane, right? Or that means I need to use operator dot n dot k mean the project, right? Project down to the xy plane, n vector dot k, right? N dot k, and you will get the scalar dx dy, right? This is the formula for projecting to the xy plane, project down. Right? It's a project to side on the side wall, side plane, okay, xc plane. You will use you must use j n dot j. You got dx dc, dx dc. Right? Okay, different from dx dy. Dx dy is project n dot k. Right? I define the unit vector for you. Go around is x I, go around is y j, go around is z axis k, right? Okay, something like this. Okay, I use n dot k d sigma. Okay, I use dx dy. Right? If you dot n dot j d sigma, the area, the 2D area, we come to dx dz, and project is right. Project n dot I, d sigma, okay, to the 2D and the region, to the region, the 2D region on yz plane, yz plane, dy dz. Okay, this is area direction, depend on you take the projection to some plane, right? Okay, go along with the formula. Okay, in this case, I told you I need to project down to the xy plane. Okay, I got it. This is the formula: n dot k d sigma equal to dx dy. What about n dot k? Okay, what is the n dot k? I show you n vector. N dot k, n vector del curl g by curl x I, curl g by curl y j, curl g by curl z k. Okay, dot is the vector dot k, and divided is magnitude g, magnitude of g, curl g by curl x square plus curl g by curl y square, curl g by curl z, curl g by curl y square, curl g by curl z square. Right? Okay, if I use the dot operator, I dot k 0, right? J dot k 0, k dot k 1. Okay, in this case should have n dot k. Final result, you will get curl g by curl z. curve g by curve x square, curve g by curve y square, curve g by curve z square. Okay, surface integral, I forgot. It's another one integral, right? Surface integral on region is a two double integral, and double integral, and there is a two integral operator. Is the surface integral, and a line integral just is only one integral, right? And surface integral there are two integral. I call that double integral. Uh, okay, double integral. N dot. N. Okay. So n. Sorry. D sigma, right? D sigma. You get dx dy divided n dot k. Okay, n dot k. D sigma is dx dy and divided uh, sorry, divided dx dy as curl g by curl c, divided the square root curl g by curl x square, curl g by curl y square plus curl g by curl c square. Okay, and swap the below side and become to square root curve. Okay, let me use the small and shorten symbol curve g, right? Something like this. G y curve g by curve y, right? Square, and g curve z square, and d dx dy divided curve g g z, right? Okay, like this, something like this. Okay, sometimes the problem different. Define the surface like this. C equal f function f. There is an independent variable x and y, multi-variable. C equal the function f, like this. Okay, and definition is the surface g x y is the surface. C equal to C. That means you must okay change to another side, become to G X Y C equal uh, mm, okay, move to another side, become to C minus F X Y. Okay, this is the G function, this is a surface function. Okay, you need to find out the unit vector of G function. Del G divided is magnitude G. Okay. What is G function? Curve G by curve X, right? Curve G by curve X, curve G by curve X. Okay, you got curve F by curve X by curve X. Okay, it's a minus negative curve F by curve X. negative again, negative and negative. So fy yj and plus okay 1 okay k divided square root f x square f s y square plus 1 plus 1 n dot k n dot k n dot k n f minus x I s y is minus f by y j plus k square root f f by x square y square plus 1 dot k, right? Dot k you get I dot k0 j dot k0 k dot k1 you get is fx2 plus y square plus 1 in dot k. Okay, that's it. The final solution for n dot k. And then if you need to figure out f vector integral f dot d sigma, right? Okay, the principle of f dot d sigma. Sigma is a vector, and the surface equal uh, the surface f dot n d sigma. Okay, this is the formula is basic. The formula which one is better depend on the technique integral. The technique to integrate to find out the solution surface integral. It's either use the right side or use the left side, right? Left side and right side. Which one is better? You take that formula to solve some problem. For me, I suggest you to use the right side. Is very good. It's good for now for uh, this class. This class enough for right side. Uh, okay, the better for you. I will use the example to teach you. Uh, I think it make you understand easier. I will show you example. Determine the surface integral. Surface integral. Okay, for the f vector is xi plus yj. Right? F vector xi yj on the surface, right? On the surface, equation is x square plus y square plus z square equal to 1. Okay, and this I will show you this. This is the sigma, right? Okay, so vector f is the surface, right? Surface equation. The surface equation and the g, because I told you I define the surface function. The surface function, right? The surface floating on the air inside and around is the x, y, z Cartesian coordinate. Define the space. I use x, y, z. It's a Cartesian coordinate. Okay, on the surface, the surface function is the x square plus y square plus z square equal to 1 and equal g. Function g is the surface because I define function g, right? The surface, okay, surface on the series space c equal x square plus y square plus z square minus 1. This is surface function. You fix it out. N vector equal to del g divided magnitude is magnitude of del g, magnitude of del g. Now curl g by curl x, you got 2x, right? Curl g by curl y, curl g by curl y, right? And g by curl y to y square, or you got 2 square and plus 2c, and okay, and the last term becomes to 0. Okay, divided square root 2x square plus 2y square plus 2z square equal 2x plus 2y plus 2z divided square root 4, right? X square plus y square plus z square. Okay, I put out of the square root. I get 2x plus y 2y plus 2z. Okay, and put out of the square root function. I will get it to, okay, stay outside of the square root. Use x square plus y square plus z square, right? Okay, the two. Okay, let me put out the factor to out of the parentheses. I get it x2, and okay, top term and real term cancel together, become to here x2 y and z, plus c. Okay, oh sorry, okay, sorry, I forgot I j k, right? Okay, the operator is a del operator. Is the operator of the vector I j k. There is I j k too. Okay, it's I j k, right? Like the one j I j k. Okay, the below term is square root x square and y square and c square, c square become to 1. This is the problem given. X square y square z square equal to 1 because the problem given. Okay, I use that relation, compare with the below term, causing you get 1. Alright, 1. That means the unit vector, you get the final solution for unit vector I xi plus yj plus zk, because a below term become to 1 already. N vector xi plus yj plus zk. Okay, I project the surface function down to xy plane, instead Solving the 3D space, you will solve write the area, right? The double integral, right? Region area. You solve by double integral, instead. Very easier than solve by 3D space. Uh, okay, and the definition is the surface project down to the xy plane. You get this is the solution, this is the formula, and n dot k d sigma, n dot k d sigma equal dx dy. Okay, dx dy. N dot k. Okay, let me use this line for so n dot k in oh sorry, the magenta color, sorry, n dot k equal is dot k vector equal I dot k 0, j dot k 0, z dot k dot k is 1, right? Okay, you get c. Okay, d sigma. Right now you got the solution. D sigma is uh, scalar d sigma. Right now in the d sigma it's a scalar, it's not the vector anymore. You is the scalar. d6 dx dy divided z, because n dot k equal z. Okay, move to another side and do the below term, right? Okay, d sigma is the dx dy z. Okay, the solution is solution of f dot d sigma, right? Surface. Another way you can solve the with surface integral, right? Surface integral f dot then n d sigma, right? And by now you got the d sigma already. And this one, did the solution, did the formula for d sigma area. Okay, I will use the right side of the formula to use for solving the sector integral. If what is the s is f is x sorry uh, f is xi plus yj, right? This the problem given. F xi plus yj plus zk. Okay, dot n is, oh no, I forgot. No, okay, turn it back. Okay, this is the problem given. Xi plus yj, enough. Dot n is xi plus yj plus zk, right? And d sigma I dot I, or the x square, x times x square, I dot j 0. Okay, don't care about different direction, just care about the same direction, right? Same direction. I dot I, okay, x square, j dot k, y square, right? And k dot no, right? Okay, vector f and never have the k direction. Okay, the end of x plus y, x square plus y square, enough. And d sigma, the d sigma is d sigma. Okay, look at dx, right? Dx and c. What is z? What is z? Okay, you find out the relation is the z and x and y. X, y, z, okay, relate together, right? You need to find out the special, the function, how is x relate on z, right? Okay. Mostly you will get that function from the problem. The problem is given. Uh, okay, over here the function of the surface, function of the surface x square y square plus c square equal to 1, right? And if you need to z equal something right side, you must, okay, move to another side. Okay, that means you get c equal x square, sorry, uh, okay, get more detail better. Okay, step by step. X square plus y square plus c square equal 1. Okay, move to another side. 1 minus x square plus y square, right? Okay, and equal z and c square, and c equal 1 minus x square plus y square, and take square root on the right side. Okay, you get the c is, you get what the c is already. Okay, this I need to change by dx dy divided by z already. Okay, I will show you back color is the new line. D sigma is a dx dy, okay, divided by square root 1 minus x square plus y square, right? Okay, I will show you what is the shape, surface shape, x square plus y square and z square, right? Sphere, right? Okay, curve the sphere, something like this here. Okay, the radius of the sphere 1. It's 1. It's 1. X sphere. X, Y, X, Y, Z. Yeah. Okay, when you project down to the XY plane, you will get the 2D, right? Okay, I will show you the 2D like this. X, uh, X, uh, okay, X, Y, X, X, Y, right? And inside of the area, the region is circle. Because the project and the sphere, right? The ball. Okay, the ball shape, right? Project down to the XY plane. You will get the circle. It's circle curve, right? Circle curve on the XY plane. Something like this. I write on this. It's a below picture, below in the equation like this. R is 1, and this curve, okay, the formula x square plus y square plus z square equal to 1. 1 is the radius, and when, okay, you put it down, okay, project down to the xy plane, c is a 0, c is a 0 because it's not height, no height, right? Just only x and y. That means the circle is x square plus y square plus c 0 equal to 1, and the circle radius is 1. something like this. Okay. Why did I analyze this area, this region? Because I need find out the lower limit, upper limit of the surface of the region. Okay, the double integral. You have ever learned double integral before, right? In the last semester. Okay, double integral is uh, double integral is the area, it's a region, and inside of the lower limit, upper limit, right, depend on the function, and outside, right, outside the limitation is the value, is value. Why is value is outside limitation, outside use upper limit is value, lower limit is value, and inside upper limit is the function, the lower limit the function as well, right? Something like this. Okay, show you how to find out the limit, right? The limit, upper limit, lower limit. Okay, it's the inside integral, inside. Alright, the internal integral indicate with respect x, right? X. Okay, that means lower limit. You focus on x, right? Because you integrate respect with x, right? And I will focus on x. Like this. You keep x direction. Okay, come from okay, start from left. Okay, move to right, okay, the x-axis, move to right, start from left. Okay, move to right side here, move. Okay, start at x, right? 0 is x equals something, right? The lower limit, and x equals something is x1 x2, right? Okay, x1 come from, okay, if you focus on the quarter of circles, quarter of circle, it's one quarter, 0 to 90 degree, right? Something, right? That means if you need to complete the circle, you need to multiply by 4. Okay, this is the quarter, right? Okay, multiply by 4, you get completed circle area, right? Okay, I use just as a quarter, 0 here, x0, move to outside curve. Outside curve is x square x, right? 1 minus y square root here. Okay, it's difficult. How to solve this integral problem? Okay, this function, I think it's too difficult, and mostly is mostly use another technique to help you solve this problem. Okay, that special technique. Yeah, okay, I will tell you, right? You use the all right, polar coordinate. You need to change x, y with the Cartesian coordinate to be polar coordinate. Okay, it will help you solve it. Is solve the problem easier. Okay, have right here. It's a, you take the square root of what to square root the difficult. It's harder to solve this. If you change to the new coordinate, okay, to make you solving easier. Okay, I don't know you have ever known about polar coordinate before. I don't know. I will show you about this. The polar coordinate is okay. I refer to some try and the Thai book. I hear that by me. I show you this. That book is okay. This very short chapter. Uh, right here, here, and lecture book, and this Thai book. Chapter number 7. Chapter number 7. Okay, chapter number 7 is the polar coordinate. Okay, and this chapter it tell you and teach you about okay the general case. It not just included about polar coordinate, and this chapter is show you and teach you uh, on of the coordinate, right? It can be transformed to another the coordinate system. Okay, this is the principle transformation of the multiple illegal. This one. Okay, I just teach you a little bit from the chapter 7. Okay, the polar coordinate. Okay, the polar coordinate is okay. Come back to the direction note. The polar coordinate is polar coordinate. X equal right, r cosine theta and y r sine theta. Okay, you see here it's r is the radius. Okay, let's see, and the theta. Okay, the relate on x and y. You need to find out the relation of r theta x y. You must know about this first. Otherwise, you could not transform to another coordinate system. And you must know about what the relation, the new coordinate and the old coordinate, how its relation is, and you must know about first. Okay. This project on x, right? You got r cosine theta equal to x, right? And if you project two vertical axis, you will get you will get it. You will get it r sine theta equal to y here. Okay, the polar coordinate and dx, dy, r dr d theta. Okay, this is the relation dx dy and dr d theta like this. Okay, you need to transform xy coordinate system to polar coordinate system. This okay, I forgot write the system on here. The polar coordinate system. Okay, this is the relation x y r theta dx dy r dr d theta. Okay, I forgot something. Okay, the double integral you can interchange with dx. Okay, indicate dx outside, dy inside, right? Okay, you can swap the dx and dy. Which one is first, right? Which one is first, the better and easier. You forgot on that. You interchange. It can be interchanged together, x and y. Okay, right? Something like this. Okay, sure. I will write on here. Here is a 4, same. X plus y square. Okay, dy dx, right? Okay, if dy it is in the internal integral is y is 0, right? And this y is square root square root 1 minus x squared, right? Okay, and this case, dx inside or dy inside is not it not change. Okay, it's hard, same, it's very hard to solve. Same thing, dx go outside, dy go inside, not change, the same, too hard to solve. uh, Okay, in the polar coordinate system, you interchange the coordinate system x, y Cartesian coordinate to the polar coordinate. How is easier, right? I showed you how is the system. Polar coordinate system easier than the Cartesian coordinate system. Okay, uh, I take its previous formula from above. Okay, this is x square plus y square dx. Okay, dy inside dx, uh, integrate, sorry, equation, square root 1 minus x square plus y square. Okay, something, here is the Cartesian coordinate. When I change to polar coordinate, say that r cos theta is x, right, square. Okay, surface. Okay, give me don't, okay, okay, the limitation, let me, okay, leave the surface first. I don't specify on the upper limit, lower limit right now, right? I just show you how you interchange to the polar coordinate system first. Okay, let's see here, and r sine theta, square, right? X equal to r cosine theta square, y equal to r sine theta square, and dx dy change to r dr d theta, and okay, square root, bottom term, square root 1 minus r square plus y square. Okay, r square plus y square is, okay, I just derive this zone, r square, sorry, x square plus y square, use the orange color, and r cosine theta square plus r sine theta square. Okay, okay, move r outside of the parentheses, uh, inside of the bracket, cosine theta plus sine theta square. Okay, and in the trigonometry identity, and or the property of the trigonometry, cosine square plus sine square is, okay, 1. That means r square plus y square equal to r, right? Equal to r. Oh, r square also. Oh, sorry, r square. Okay, because it r square move out of cosine square theta sine square theta reduce. Okay, you got r square. Okay, uh, okay, this zone I transform the xy Cartesian coordinate to polar coordinate system. Okay, r right here, uh, become to r. Okay, I use the new coordinates, right? R move out, right? Move out of the bracket, create a new bracket, and move r outside of the bracket, inside of the bracket, cosine theta square, square sine plus y plus sine square theta to become to 1. Depend on the property of the trigonometry. 1. Yeah. Okay. And r. Okay, the rest of term r dr d theta divided square root 1 minus r square, right? And limit. Okay, lower limit, upper limit for inside article, inside article. Okay, r mean radius 0 to 1. Okay, 0 to 1. And theta 0 pi pi over 2, pi over 2, 90 degree. Okay, I look at this article problem. Look simple, right? Look easier than the Cartesian coordinate, right? R square minus r square and r, okay, become 2 3 r cubed dr d theta. Okay, use substitution technique. Okay, use substitution technique. I assume u is square root r minus square, right? Okay, 1 minus r square, 2 less to 1 over 2 power, and du by dr. You got the 1 over 2 bracket 1 r over r square, or 1 over 2 minus 1 power, and d 1 r square, right? Okay, I just okay, this part you get minus, right? This part is a minus 2r, right? And these 2 and 2, okay, cancel together, become 2 du by dr equal minus r and 1 minus r square, and less to 1 over 2 power. Okay, and dr is minus square root 1 over 1 minus r square divided r du. Okay, use substitution technique. Okay, I change to the blue color. Okay, substitute back to the problem, medical problem. 4, okay, we still have 4, one of the double integral. See, integral 0 to pi over 2, 0 to 1. Okay, and r minus r square, right? And repeat the orange color. Okay, this one 3, orange color is square root 1 r minus r square and r, right, and du. Okay, just change to the set the r to be du first for solving inside of integral. Okay, cancel together. It's square root below and top term cancel together, and r1 become to 3 become to r2 r square. Okay, 4 0 and pi over 2, and this minus r square du, right, and d says that. Okay, you just solve inside integral. Okay, what is r? Because it come from here and from here, right? R square is u square minus 1, right? Okay, I take it to the original problem. Okay, the problem 4 0 pi over 2 and the minus sorry, u. Okay, it's a minus r. Okay, I just need r minus plus. Okay, we come to minus r square 1 u square, right? Okay. Let me uh, look at again. Okay, step by step is better because maybe you were wrong to solve this. Okay, if I move here, u equal 1 over 2. No, 1 minus r square. And you take u square and 1 minus r. Okay, take move to our opposite side. You will use r square 1 minus u square. Okay, and this one minus r. Okay, I think of r plus r. Okay, become to minus r square and u minus 1. Okay, come back to this u minus 1 du d theta. You got minus 2. Okay, this is uh, okay, d theta, d theta. Okay, you change back to the original variable. 4 0 pi over 2, and you write 1 minus r square 3 over 2 minus u. U is 1, right? U r square 1 over 2, right? Here u okay, r0 to 1 d theta. Okay, u, okay, u cube equal 1 minus r square uh, okay, 4 is 4 pi over 2. Okay, put it 1 1, right? 1 is 0, right? Okay, 1 minus 1, okay, is 1 over 2. We come to 0, minus 0, which is 1, 0. Okay, that one term becomes 0, and minus 0. Okay, the one term becomes to 0, and okay, the second term, okay, I move to a new line. 4 0 5 over 2, inside this 1 minus 1 over 3, the theta, right? Okay, 4 pi over 2, this is 2 over 3 d theta. Okay, we come to 2 over 3 theta, right? And multiply, okay, sorry, multiply 4 0 and pi over 2 equal 4 2 3 pi over 2 minus 0, okay, equal 4 pi over 3. Okay, I'm done. is the answer. The final solution is in the vector integral. There are the two theorem. The three theorem is really for help you solve complicated problem. There are two theorems. Theorem are the divergent theorem. Refer divergent theorem. Divergent di, divergent theorem. This theorem is okay. This is the divergent theorem. The special theorem for tell you solve the complicated problem. Divergent is use the relation to up level from the line from the Green theorem. Green theorem is okay. Green theorem is a closed curve f dot dr equal curve q by curve x minus curve p by curve y. Okay, the region dx dy. This is Green theorem. Cos curve, right? Cos curve related on region. Cos curve composed of two curve. Okay, close start point and the end point. That is the same point, and they call that is cos curve. Line integral for cos curve equal to the region, and the region is curve cover, and cover together become inside of two curve become two region is the area. I call that is the Green theorem. This Green theorem. It's a help you use double integral instead of line integral, two curve summarized together. Okay, the region integrate the double integral is easier than uh, find out the value line integral for curve curve number one and curve number two. How many the curve generate to be cos curve, right? Okay, depend on number of the curve to be cos. Okay, this is the theorem, in theorem, help you solve complicated problem. Okay, for divergence theorem, okay, the same way, use the relation. Okay, in this case, the relation is the cos surface. Is the cos surface. The cos surface is f dot n vector d sigma, right? Okay, equal the relation is volume. Okay, three triple integral del dot f, del dot f, triple integral, right? The volume integral the vector, the volume. Okay, this the relation for cos surface become to volume is the up to upper level, up level from the Green theorem here. Okay, if you have more than the surface, more than the surface, more than one surface, right? Okay, generally it's closed curve. We call it closed curve composed of one surface, another surface, right? Close together, the start line and the end line. Okay, just the same line, so start point and the end point. Okay, start point the one curve, another curve, the start point the same, the end the same as well. That means the cos curve and the cos surface same thing. Cos surface is number of the surface put together become to volume. It's volume. Okay, the idea I just review little bit to you, and I'm not dive into dive deeper into the more detail for you. I just review how is it how is the divergence theorem. Okay, the last one topic, the last one theorem, that is the Stokes theorem. Okay, because cos curve, if you the divergence theorem is cos curve, right? Okay, it's more than one solution. It's more than one solution. Okay, the same thing. I just taught you. I just taught you already. The previous example. It's not just only one surface, because divergence theorem is more than one surface, because the two surfaces assemble together become too close, right? They become too close. You can use the volume instead to solve. It's more than one surface cos, right? Cos surface. And the Stokes theorem, same thing. The Stokes theorem is STOK. Uh, S theorem. Okay. How how the relation of the surface and line equal. Okay. This idea for Stokes theorem. This is line equal f dot dr equal the surface s curve curve no curve f, right? Curve f is the right cross, right? It's curve f dot n vector and ds, and the curve f mean curve f, right? Curve f vector mean del cos f, right? Okay, del cos f. Del cos f dot n d sigma. Okay, this is the idea of the Stokes theorem. Okay, you can use the surface or line integral. It's a line integral. It's not cos curve. It's a line integral. It's okay. It's cos curve too. The cos curve. Okay, the cos curve use the surface, right? The edge of the surface. The edge of the surface here. Okay, this is the relation of the Stokes theorem. Okay, I'm not deeper, yes, detail more than this, because it's too difficult to learn about now about the more than detail, because this is the advanced course. Okay, you can learn about this uh, in the master degree. Okay, right now I think enough for you at the surface integral.